All right, what's up, ladies and gentlemen? Thank you again for tuning in to another episode of Health Sucks. Let's talk about it. And for our new subscribers, we ask that you like, comment, drop a subscribe at the bottom. And for the people that are returning, thank you for watching another video. Let's get straight into it. So today we're going to go and talk about the brain, and we're going to get a better understanding of the cranial nerves and a little bit of the autonomic and peripheral nervous system. So first off, we're going to bring out Dr. Tato so he can give us a better understanding of the lobes, and then I'm going to give us a better understanding of the cranial nerves, and then we're going to bring John back out for the last bit and show us a little bit about the peripheral nervous system. So I think right now we should just go ahead and get Dr. Tato. Dr. Tato!
Oh, hello. So, today we're talking about the brain. Now, we're going to start with a general rule. For the brain, the more inferior and medial it is, the older and more primitive it is. So we're going to start from the bottom up, and we're going to describe the brain. Now, we can call the brain different sections, and we're going to use the suffix cephalon. Cephalon means head. So these are the different sections of your brain, and we're going to start with the myelencephalon. Myel means spine, so this is your spine head. This is the portion of your brain which is going to be the intermediate between your brain and your spine. This is going to be this area right here that we're going to call the medulla. The medulla is responsible for breathing, heart rate, and blood pressure. Moving up, we're going to get into the metencephalon, which is going to include the pons and the cerebellum. The cerebellum is mostly responsible for all of your voluntary conscious control. So if I'm running, if I'm climbing, if I'm swimming, I'm using my cerebellum. My pons is going to contain some other things the medulla doesn't have, and it's going to act as a bridge between the spinal cord, and the rest of the brain. Moving up into our mesencephalon, mesen means middle, so this is our midbrain. This is going to contain things like visual centers, wake and sleep cycle control centers, and things like that. The diencephalon is going to sit right above that midbrain, and it's going to contain the thalamus, the hypothalamus, the epithalamus, and the subthalamus. So everything thalamus is diencephalon. Your thalamus acts as the grand central station. It is the thing that will take all sensory information coming to and from the cerebral cortex. Everything conscious that you think of has to pass through the thalamus. And finally, we get to the telencephalon. The telencephalon is going to be what we call your cerebral cortex, the actual thinking part of your brain that we as humans specifically have. So we're going to break that down into 4 lobes. The frontal lobe, which is going to be mostly for motor control, as well as impulse control and higher order thought. Your parietal lobe, which is going to contain the majority of your sensory information, as well as act as kind of a network system for the rest of your lobes. The occipital lobe, which is going to be responsible for your vision. And your temporal lobe, which is going to be responsible for memory and hearing. And that is how we break down the brain.
Oh, okay, that guy never disappoints. So now we need to talk about our cranial nerves. Cranial nerves are very important because not only are there 12 of them, but we also have 4 of them that deal with their eyes alone. And that's very important for us to be able to see and do things on a daily basis. And 4 out of these 12 also deal with the parasympathetics, which we're going to let John get more in depth on later. So now I know this looks like a lot, but you know we have a mnemonic for you. So the mnemonic for these 12 cranial nerves is going to be OOO, to touch and feel very gross vegetables, aha. So since we were talking about our special senses, let's go ahead and jump into the very first cranial nerve, which is olfactory. Olfactory is going to be for your sense of smell. To be able to take a deep breath, that is your olfactory nerve working. The second one is going to be the first one for your eyes, and that's optic. That's being able to see everything in front of you. And then 3 is going to be ocular motor, which is movement of the eye. And then 4 is also going to be movement of the eye, but it's a little more in depth. It's for looking down and in. So if you were walking downstairs, you'll be using your trochlear number, cranial nerve 4. So 5 is going to be your trigeminal. It's going to be tri because there's 3 portions of this nerve, and it goes over your face like this. And this portion is going to be the ophthalmic. This portion is going to be the maxillary, and then this portion is going to be the mandibular portion of the the trigeminal nerve. So number 6 is going to be the abducens, and this is also going to be motor of your eye, and this for your lateral rectus, which means you'll be able to look laterally. It'll pull the eye laterally. 7 is your facial nerve. So facial is exactly what it means. All these facial expressions that you can see me making, all of those, that's from my facial nerve. Vestibulocochlear. So vestibulocochlear is going to be for your balance, and it's going to be for your hearing. So the reason why you can hear me right now is because of cranial nerve number 8. So glossopharyngeal number 9 is going to be, we call it bitter back 9, and it's because it's for the taste for the back portion of the tongue. Then you're going to have the vagus nerve. And from what we learned in school, we always make a joke and it's saying vagus controls everything. Literally everything else. Your heart rate, the way you breathe, anything you are not consciously doing, your vagus is doing it for you. So thank you, cranial nerve 10. Now, the 11 is the spinal accessory nerve. This one gets a little bad rep because people don't like to put it in the 12 cranial nerves, but it is for our trapezius muscle and our SCM, sternocleidomastoid. And the last but not least is going to be the hypoglossal nerve. And hypoglossal is basically going to be the movement of the tongue. So being able to move the tongue everywhere you need it to go, when you're chewing your food, moving it around, that's what that nerve is for. So now, we are going to go ahead and get a better understanding of where these are in the body, and I think we're going to need Dr. Tato for that. Dr. Tato.
All around me are familiar faces, worn out places.
Okay, so a physical way to remember where these nerves come off of the brainstem, we're going to play a little game. I want everyone to stand up and do it along with me. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me explain. 1 is olfactory. It's going to come right here. 2 is going to cross as your optic nerve because it has the optic chiasm in which it crosses. 3 comes out of your midbrain. 4 is the only one which comes out of the dorsum of the midbrain, or the dorsum of the brainstem in general. 5, I call it your moose. It sits on sides of your pons. 6, 7, 8 come out of the pontomedullary junction, the area between the pons and the medulla. 9, 10, 11 is your spinal accessory, so part of it comes out of the medulla and some of it comes out of the spine below it. And then 12, the only one that comes out between the olives and the pyramids of the medulla. And with that, let's head over to the autonomic nerve.
Wow, that was fun, guys. Now let's do it. We talked about the brain, which is a part of the central nervous system, and we talked about the cranial nerves that come out of the brain. And I just wanted to give you a better understanding of how those relate to the peripheral nervous system and/or differ. So, how do we separate it? Central nervous system, brain, and spinal cord. We're also going to make another video next week on the spinal cord itself and talk about the dorsal-column-medial lemniscal pathways and all the other nervous pathways that come up through your spine and go out through your spine. But today, let's focus more on the peripheral nervous system. So, just to break it up, you have the autonomic nervous system and the somatic nervous system part of that. So, your brachial plexus, which we covered, which is a part of the PNS, but it's more somatic. It's the muscles we have control over, right? Now, what about autonomic? You also have the parasympathetic and the sympathetic nervous system. Now, I did add the enteric here, which is something that is new, or at the very least, we're now considering it as its own organ or system that is plays an effect on the parasympaths with the vagus nerve. That's its connection. This is what we call the gut-brain axis. But more on that later. Let's talk about parasympathetic, sympathetic. So where are they at? What's the difference here? Sympathetics is going to be from T1 to L2, and that's going to be fight or flight. These are, this is the system that, which I'll let Dr. Tato get more into details on what it does, but this is the system that inevitably, if there's a bear in front of you, you're either going to decide to fight,
Oh, look, an eagle!
or you're going to flight. Adrenaline's pumping, you gotta go. That's what that is. Parasympathetics, on the other hand, is rest and digest. So if you're not running from a bear, you probably are worried about your food and being able to digest your food, and you're more relaxed, in a relaxed state. This is otherwise known as your craniosacral. So this is going to be from your brain to your sacrum, the sacral plexus and all that. But now earlier we talked about cranial nerves being a part of parasympathetic. So if it's cranial, which cranial nerves? Well, we have cranial nerve 10, 9, 7, and 3. So for cranial nerve 10, like I said, the vagus has connections all throughout your GI system, and then it comes from your brain. And it also has connection to your enteric system, which is going to inevitably play a big role in gut health. Next, we have if you hear chewing in the background, it's just my dog, so don't mind that. Anyway, we have glossopharyngeal, cranial nerve 9, and facial nerve, which we talked about with facial expressions. And we also have the oculomotor, cranial nerve 3. This is going to be for, you'll notice some drug interactions may play a role with cranial nerve 3 in its ability to constrict the pupils. That's a parasympathetic innervation. You'll notice that with some drugs. Anyway, a big topic or thing that we need to know with these are the synaptic fibers, what they look like, and what are the neurotransmitters and the types of receptors that go along with these two, sympathetic or parasympathetic. I could explain it real quick, but I think we'd have more fun by allowing Dr. Tato to come out here and give you guys a real idea of what this is supposed to look like. So, Dr. Tato!
So, in the autonomic nervous system, every fiber we can classify as sympathetic or parasympathetic. Sympathetics have certain characteristics to them. For example, they have short preganglionic synapses and followed by a very long postganglionic neuron. An example of this, and the reason for it, is because adjacent to the spinal column, you have a collection of cell bodies that we call the sympathetic chain ganglion. Now, the nerve itself is going to come out of that root at that level and immediately synapse with that sympathetic chain ganglion. From there, another long axon is going to take it all the way down to the target organ, where it will then innervate that area. Because it is sympathetic, the traditional neurotransmitter or hormone that we associate with that would be adrenaline or noradrenaline. We call it epinephrine and norepinephrine. That adrenergic receptor, the one that receives adrenaline, is going to have different classifications based on where it is in the body and the heart. I won't go into those details too much. Parasympathetic is going to have a long preganglionic. For example, the vagus nerve, cranial nerve 10, starts, remember 9, 10. It starts in the medulla, and it's going to go from the medulla down the body, around the esophagus, and end at the stomach, where it's going to wrap around both sides of the stomach. That's a very long way to travel for a neuron, and that's just the first neuron, so that's the preganglionic neuron. Once it's there, it's a very short distance where it innervates the target organ. We mostly use acetylcholine for the parasympathetic system. The exceptions for this is that sometimes the adrenergic is going to actually be an acetylcholine based. So we have to differentiate between the postganglionic neuron and the preganglionic neuron. A bunch of scientists figured out that nicotine would stimulate only the preganglionic synapse and not the post. So that's what we call them nicotinic. They also found that for specifically glands, that muscarine, a chemical usually found in mushrooms, would activate the postganglionic neuron and not the preganglionic neuron. So when you're running from a bear, do you sweat more or less? You're going to sweat more. And does your hair stand on end when you get scared? Yes. So those are sympathetic responses, but all glands have acetylcholine as their hormone. So this is the exception to the rule of all adrenergic receptors. So just sweat and piloerectors are going to be muscarinic receptors in the sympathetic nervous system. And that's the only exception to the rule.
Wow. Thank you guys one more time for coming in and watching this video. I thank you for sticking with us till the end. And if you guys have anything to say, please do so now.
Don't forget to like, comment, subscribe. Let us know how you feel. Let us know what you don't like, what you do like. Just let us know.
Thank you guys. Health sucks. Let's talk about it.
Later.